Hello everyone, welcome to Basic Electronics Tutorials. In this video, I am going to take up the third numerical on diode biasing. Let me read out the question first. Calculate the reverse saturation current for a silicon diode which passes a current of 10 milliamperes at 27 degrees Celsius for a forward bias voltage of 700 millivolts. The question is pretty simple. We are asked to find the reverse saturation current when the diode has an input applied voltage of 700 millivolts and the diode current is 10 milliamperes and the room temperature is 27 degrees Celsius. Let us start with the solution now. Let us quickly write down the given values. We are told the diode current is 10 milliamperes. Room temperature is 27 degrees Celsius. And the applied forward bias voltage is 700 millivolts. Right. We will now use the Shockley's equation for defining the diode characteristics, which is given by ID equal to IS multiplied by exponential of Vd divided by eta Vt minus 1 amperes. Let me call it as equation 1, where ID is the current across the diode, IS is the reverse saturation current, Vd is the applied voltage, eta is the ideality factor. Please note the value of eta for silicon based diodes is equal to 2. And lastly, Vt is the thermal voltage. Please note the value of thermal voltage is not given in the numerical. So let us compute that. The equation for thermal voltage is Vt equal to K into Tk divided by Q. Let it be called as equation 2, where K is the Boltzmann constant and is equal to 1.38 into 10 to the power of minus 23 joules per Kelvin. Tk is the absolute temperature in Kelvin. This is equal to 273 plus temperature in degrees Celsius. For the current numerical, the value of temperature is given as 27 degrees Celsius. So, Tk will become 273 plus 27 equal to 300 Kelvin. Lastly, Q is the electronic charge magnitude and is equal to 1.6 into 10 to the power of minus 19 coulombs. So, let us now compute the thermal voltage by substituting these values. Therefore, Vt is equal to K into Tk divided by Q. K is 1.38 into 10 to the power of minus 23 multiplied by Tk is 300 Kelvin divided by Q, which is 1.6 into 10 to the power of minus 19. You will get the value of Vt as 0.0258 volts. Right? Once we find the value of Vt, we can substitute everything back into equation 1 to find the value of the reverse saturation current. But before that, let me rearrange equation 1 for Is here. We get it as Is equal to Id divided by exponential of Vd divided by eta Vt minus 1. Let us now substitute the values here. Id is given as 10 milliamperes. Vd is the applied input voltage, which is 700 millivolts. Eta for silicon based diode is 2 and the value of Vt we just computed is 0.0258 volts. When you compute this, you will obtain the answer as 14.2471 into 10 to the power of minus 9 amperes. This is the value of the reverse saturation current of the diode for the given specification in the numerical. Well, with that we have come to the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more tutorials on basic electronics. Thank you for watching. Have a good day.